Hello, this is Douglas Rumbaugh, and welcome to Linux Back to Basics, Episode 9. In this episode, I'm going to be talking, as promised, about process management. I need to do a bit of a disclaimer going into this video, though, and set expectations. Process management is a very deep, very complicated topic. There's a lot there. There's a lot of theoretical stuff there. There's a lot of operating system stuff there. I'm not going to be talking so much about that because this is a very basic introduction to it. So this video is not going to be a substitute for the process management section of your operating systems class. All right. This is just to give you an idea of how you can interact with Linux's process management system in useful ways. So I just want to get that out of the way. With that said, this video might come out in two parts, depending on how long it runs, rather than uploading some 30-45 minute behemoth of an episode. Just because even with just the cursory, here's high level 30,000 foot view of how Linux process management works and what that means to you, it's still a lot of content. So I'll make that call when we're done, but you might see two videos instead of one that are called episode 9, and that's why. Let's dive right in with that preamble out of the way. What is a process? Process management obviously involves the management of these things, but what exactly is a process? I'm fairly certain that I mentioned this in episode 8, where a process is basically any program that is executing on your Linux system, or for that matter, any system. Process management is universal across all operating systems for obvious reasons. Some of this stuff is going to look very familiar because it is very similar to job management. So job management, what we talked about last time, is an abstraction of process management. So it takes that behemoth of a subject that is process management, and it distills it a little bit and makes it simpler and easier to work with. So you lose a lot in doing that, but for certain things it's just much easier to do, and that's why it exists. We're going to dive a little bit deeper than job management here, though. So let's first talk about why process management is important in comparison to job management, because I think that's a worthwhile topic to discuss. Job management, as just the brief overview, in case maybe you didn't see that video or you saw it a long time ago, is basically managing programs that are executing within a particular bash session. So right now I have, and I realize I'm gesturing with my hands, which doesn't help you very much. I have a virtual terminal here, which it has a bash session inside of it. So if I were to, for example, run this job test again, which you should remember from the jobs video, and I'm just going to go ahead and redirect the output to /dev/null, which just throws the output away. It basically deletes it. And run that in the background. So if I hit jobs, you'll see I have job number 1 is running, and it's this job test thing. So that's great. Problem is, let me open up another one. I'm going to run that same command, job test.py, redirect to dev null, run it in the background. So now, job 1. So I have two different instances of this program running right now, and they both have the same job ID. So in order to kill one of them, if I should want to, I'm going to have to not only specify the job ID, but I need to be in the right bash terminal. So there, I just killed that one, but this guy hasn't been touched. This makes sense because of how the way job management is set up. I'll just bring that one down too. So why might that be a problem? Well, for one thing, not every program that you execute is going to be on an easily accessible bash shell. Or it might not even be in a bash shell. Some of the operating system stuff isn't. So, for example, Terminator itself here, right? And is running inside of my LXDE desktop environment. And LXDE is running inside of a bash shell, but I don't have easy access to that bash shell, right? I'll have to either pause or abort or kill LXDE in order to get back to the original bash shell that it's running in. So if I have a program that's running inside of LXDE that's not associated with one of these virtual terminals in here that goes down, I can't kill it by job ID because I can't easily get to the right bash shell to be able to kill it that way. So that's where process IDs come in. So process IDs are different from job IDs because a process ID is not bound to any particular process, if that makes any sense. What I mean by that is, that's actually probably a really bad way of explaining it. Let me try again. A process ID is unique across the entire system, right? This terminator session right here and the bash within it, each one of those has a process ID, which uniquely identifies this terminator and this bash. Likewise, this terminator has a process ID as well, which uniquely identifies it. And I don't need to care about what virtual terminal or what bash session I'm on to be able to interact with that process as long as I know that unique number. Well, how do we find that unique number is the obvious question from there. That's kind of an important thing. So for this, I need to introduce a new command, and that is ps. The ps command is going to list processes. It does basically what it says on the tin. If I press enter, you'll see I have a list of processes. Here we have the process ID number, which, as I mentioned earlier, is that unique number that it gets tagged with. We have the TTY. TTY stands for teletype. It's kind of a holdover from the days of yore when you had basically printers where your interface, right? You'd hit something, and when you hit submit, and it would print out on a sheet of paper, and it was called teletype because it's typing literally, but it's, remote from the actual computer. Anyway, that term's just held on. So this is your virtual terminal. You'll see this stuff is running in PTS/0. So this PTS/0 is actually, as I'll show you in a minute, uniquely identifying this particular virtual terminal here. If I go over here and type PS, you'll see it's now in PTS/1. So it's a different terminal. It's this terminal, not this terminal. The time represents CPU time that the process is used. I will talk about that later. And then CMD is, of course, the command that this process ID is associated with. So bash and PS. It's the English version of it so you can read it and understand what's going on. So the first thing that should immediately stand out to you is, well, great, we now get process IDs, but it's just like jobs, right? This is the PS and the bash that are running here. So this bash is actually, this process is the bash that I'm interacting with right now. And this PS is the PS that I executed up here. PID 938 and 996. Over here is the same deal, but you'll notice the PIDs are different, unique. By default, PS works like jobs in that it only lists the stuff that's bound to your particular terminal or your particular TTY. Of course, jobs does not list itself, and it does not list the bash session, so it shows empty. But if we were to, for example, kick off job test again, I'm really getting a lot of mileage out of this, like, what is it, 5 lines of code? All right, so we do that. You'll see now jobs. I have job 1 is that job test.py. And if I do PS, it shows up right over here, PID 999. I can do the same thing over here. Job test.py, direct/dev/null, run in the background. And you'll see, if I run jobs, it's still job 1, but has a different PID. Its PID is 1003 versus 999, so unique. I'm really hammering that point home. It's pretty obvious, but it's one of the important aspects that makes process management more flexible than job management. All right, so now that I have the process ID for this thing, say I want to kill it by process ID, not by job ID. We know that I can kill it by doing %1 over here, and I'll kill the job test running in this terminal. What if I wanted to run the job test running over here from this one? Well, obviously I can't do %1 because that refers to PID 1003, not PID 999, but kill accepts process IDs just as easily as job IDs. So I'm going to do a kill-9, just I like overkill. And all you have to do then is type in the process ID itself. So 999. If I head back over here now and type jobs, you'll see it shows killed. I've just killed it from over here without using a job ID. So that's all well, fine, and good, but we're still stuck right now with the problem that we can only see the process IDs that are associated with the terminals that we have direct access to here. I can't, for example, kill Terminator right now because I don't know its process ID. To do this, we have to pass an option into the PS command. So PS actually accepts a variety of different formats for its options. I'm just going to show the standard Unix format. So if I do PS and then a TAC E and press enter, that's going to give me a list of every process that is running on the system right now with the same output format. So you see we have process 1, 2, 3, 4, 5, 6, all the way down to 1008. Now I can see, for example, Terminator. So these are my two Terminators, and you'll see these guys are running in TTY1. What does TTY1 mean? Well, that's the teletype terminal 1. These PTS are associated with the TTY. So this PTS/1 is basically saying that it's within a virtual terminal. Or, well, no, not a virtual terminal, a terminal emulator, and then the TTY is the virtual terminal itself. It's a distinction I will talk about in a little bit. Now, by doing this, I can now see everything that's running. Here's my LXDE stuff. LXPanel, LXPolkit, Xorg, Xinit, StartX, and you'll see all this stuff is running on TTY1. There's also stuff that has a question mark here. These processes are not actually associated with a particular virtual terminal. This is, for example, operating system related stuff. So that's using PS to see everything on the system. And say I wanted to kill one of these Terminators. Now it's a little tricky figuring out which one is which, I'll admit, but I'm going to kill 932 and see what happens. Boom. See the other one down here vanished. I just killed it. So if I do the PS again, there should only be one Terminator rather than two. And you can see that right here. All right. So why is that particularly useful? Well, let's open up, say, Image Viewer here. All right. So this is just going to represent some application that I have running in my desktop environment. And it's misbehaving. It's crashed, not responding, and I want to get rid of it. Well, I can do that using kill. So the first thing I have to do is actually find the process ID that's associated with it. So I can do ps-tac-e again and find it. Now, this step can sometimes require a little bit of foreknowledge because the name of the application, Image Viewer, is not necessarily the name of the command itself that is running. In this case, Image Viewer is actually called gpicview. But knowing that, and you can always Google it if you're not sure, we can get the process ID of 1012 and we can kill it. Kill-9, 1012. And it goes away. So the -9 is, of course, the kill signal. That's the really powerful one that'll knock out just about anything. So that's how you kill a process by PID. I will point out now, because I'm sure that some of you will point it out, that there are other ways of doing it that don't require the process ID. I'll talk about those some other time. I want to focus in more on the low-level stuff here, and I'm also a fan of doing it this way for a variety of reasons, but I acknowledge that I am aware that there does exist alternatives to this that don't require you to look up the PID. If we stick, however, in this framework where we do have to look up the PID, you may have thought of a slight streamlining of this process. So at the moment, if I do my, let me fire up that image viewer again. Image viewer graphics. There we go. Fire up image viewer again. If I do my ps-tac-e, right now it just so happens to show up nicely at the bottom. That won't always be the case, and this is a fairly long list of processes that I have to look through. So using content covered, I believe it was episode 7, I'm going to make this process a lot smoother by doing this. PS TAC E. So this is my list of processes, right? And remember, thinking back to input and output streams, how this actually works is that I'm running this program, and that this program is pushing to standard out its output, which in this case is the list of processes. So I can actually pass that standard output as input into another program by using a pipe, as you may recall. This is handy because I can just take that list, that big long list of processes, and pass it off to a program called grep, which I believe I've already talked about, but it basically just does searching. So I can pass in a search string, and it will search the input for that string and only display the on output the lines in that input that have that string in it. So I can do gpick, for example. And what this is going to do is it's going to take my full long list of processes, and it will only display the lines which have gpick in them, which means I only get the one line here representing the process that I'm interested in. It saves me from having to look through that whole list. It's a very useful trick, something that I use a ton. And so from here, we can, of course, kill our process. Okay, so that is just the very bare basics of how this whole system works. We talked about the PS command, how it lists out processes on the system, and you can use the TAC E option to expand it to list out everything on the system rather than just the stuff that's currently running on your bash prompt that you're interacting with at the moment. Also showed how you can kill a process by ID, how you can streamline finding process IDs using a pipe and grep. And of course, we talked a little bit about what processes are. So I'm going to call that part 1 of this video and cut it here. In the next video, we're going to talk a little bit more about how processes are, or how Linux handles processes, a high-level view of the operating system stuff and how it's all arranged. And then after that, we'll talk about some additional options that the PS command has and how you can use those to further improve how you manage the processes on your system. So I appreciate you watching this video. I hope you found it useful, and I will see you in part 2.